Hello everyone. In this recording, I am going to talk about the Firewall Policy Analyzer, which a piece of software that I wrote using Streamlit, and its purpose is to analyze firewall policies and detect any anomalies or inconsistencies in the rules. So if you go to GitHub, um, you will find in my page here, you will find the firewall policy analyzer. So the description of the code tells you that it's an application that detects anomalies. It is really based on a research paper by a group of researchers, and these are the papers that describe the methodology behind the detection, the anomaly detections. I used the methodology, and I improved upon the algorithm a little bit, and wrote the code in Python using the Streamlit library, which allows us to visualize or create a web interface for the code, and makes things a little bit easier to work with. So you can follow the installation instructions and download the software and install the requirements, the Python modules that you need, and start it locally in your computer. But you can also um, uh, the code is written and hosted at Streamlit, so you can also open it in Streamlit and you can use it right away. So before I begin, I want to describe a little bit how the code works. So first of all, we need to provide the firewall policies using this format, which is a CSV format. Um, this is a text file that has the firewall rules written in or using 7 or 6 columns: the protocol, the source IP address, the source port, the destination IP address, and the destination port, and also the action. So the examples here show you, um, in this case, the protocol is TCP, the IP address, and any represents the port, and so on. All right. So I'm gonna skip diving into details about firewalls and firewall policies and rules, assuming that you already know about this. Otherwise, you wouldn't be here. And I'm gonna skip directly towards, or straight toward the code itself. If you are wondering, okay, so which vendor uses this format? Actually, none of them. So you have to, this is a standard format or vendor neutral format. So if you need to translate specific vendor firewall policies into this, you have to use a parser. I created a parser somewhere else, which it is here, for example, and this parser can take either FortiGate firewall policies or Cisco ASA policies, and convert them into a standard format. You can use this code and it will generate something useful, but it's still work in progress, so it's not finished yet. So let me go back to the firewall policy analyzer. Okay, so I'm gonna open the analyzer in Streamlit. The first thing that you see is this page with an about here, and also the first thing you need to do is to upload the rules. So where are the rules? You can create them yourself, or you can, for trying, you can go to the examples here, and you can download one of these files. So I'm going to download this one here. All right, so we'll go back and start Streamlit again, and I'm going to upload the file that I just downloaded. Okay, the file is uploaded to uh, the application, and the first thing I see here is a group of widgets. Right away I can see the summary of all the anomalies that the software uh, detected. Right. If I want to see the rules themselves, I can click on this, expand this widget here. I can see all the rules that I uploaded. You can see here I have 10 rules. Some of them are related to protocol TCP, and they deny some packets and accept others. So I'll go over these one by one. Okay, so let's go back to the summary of the anomalies. So we have here anomalies, shadowing anomalies. I have two of them. I have redundancy anomalies. There are two types, redundancy X and redundancy Y, which I will describe. And then we have correlation anomaly and generalization anomaly. So the numbers here represent the count of each one of these anomalies. If you can see the table here, you see the rules, the relationship between the rules. So rule 1, for example, is related to rule 0, and the relationship anomaly is generalization. Here, rule 3 and rule 1 are related, and the relationship is shadowing. So this means that rule 1 is shadowing rule 3, and so on. Some of these anomalies are not errors by necessary. They are maybe intentional, but some of them are definitely errors. So shadowing, for example, is an error. Shadowing means that a higher rule is preventing packets from ever reaching the lower rule. So rule number 1 here is designed so that, or it's written so that it will never allow packets to reach number 3. But the problem here is these two rules have opposite actions, and this is the issue. So we'll go over each one of these um, anomalies one by one. So let's take the errors first. So obviously we have an error here, a shadowing error or shadowing anomaly between rule 1 and rule 3, and also between rule 2 and rule 3. So let's go and investigate. So in the analysis, under the analysis header here, I see rule, I can detect, or I can click or select rule 3. So I have rule 3 here, and automatically I can see on the other select box the other two rules, 1 and 2, that are related to rule Y, rule 3. Okay, so, and these two rules are written down here for convenience. They are the same, of course, as these rules, but they are written at the bottom for convenience, so I can compare them one to one. Sometimes the rules themselves, they are far apart in the rule set, so seeing them here next to each other makes things easier for us. So why this is a problem? If you can see, rule 1 says any packet that has a protocol, TCP protocol, with the source of 140.192.37.0 and destination is any with port 80, we have to accept it, right? The action is accept. But then the second rule it has the same IP address as the source. Destination is more specific host 161.120.33.40. The port is the same, but the action is denied. The problem here is rule 1, because the destination is any, it will never, any packet that actually needs to be denied because it's going to this host will never reach the second rule, will always match the first rule and it will always be accepted. All right, so this is a problem because my intention is to deny any traffic from this network to this host and allow everything else. But that, because of the shadowing, that will never happen. And this is an error that needs to be fixed. So you can find out more about shadowing here. A rule Y is shadowed by previous rule X if they have different actions and if rule X matches all the packets that match Y, such that rule Y will never be reached. Right. The recommendation here usually means that if we can reverse the order, if we can put rule 3 on top of rule 1, we'll fix this issue. So first, we will match any packets that are destined to 161.120.33.40. We deny them, and then all other packets are accepted, which the intended behavior. If this is not intended behavior, then we have to go to the actual rule set and change it manually. But if this is so the recommendation here is to move rule Y before rule X. If this is okay with me, I can apply the recommendation and the app will switch these around. Okay, if I go back, I see nothing changed. Everything is the same. I still have shadowing, so nothing took effect. That's because if I want my action here to take effect, I have to click on Use Edited Rules. And by doing that, actually, I fixed two shadowing problems at the same time. So you see the shadowing disappear, so there's no shadowing error because the action that I took actually fixed the two shadowing problems. And if I want to see the rules again, I will see that now you see this line here is the original line that was down, but now it's in the second location, and any traffic that has protocol TCP and it's going to this particular host will be denied, and then other traffic will be accepted. So I fixed both problems. Okay, now there are more errors. Redundancies are considered errors because there shouldn't be any redundancies and they are wasting of space in the firewall set and causing confusion and causing performance problems. So I need to remove the redundancies, and I have two of them. So if I go, so rule 6 here and rule 5 are related and they are redundant. You can see here I have redundancy Y, redundancy X. So let's see what each one means. So if I go to rule 6 here, I'll start with the Y rules. So rule 6 and rule 6 is related to rule 4 with the correlation and 5 with redundancy. So I'm going to focus on the redundancy for now. So redundancy Y, you see these two rules, and the definition of redundancy here is a rule Y is redundant if it performs the same action on the same packets as preceding rule X, and if rule X can match all the packets that match rule Y. Okay, so in this case, rule Y is not necessary, it's useless, right? So if you look here carefully, you see that rule X says that any packet with protocol TCP has this source 141.92.37.0, and destination any, and port 21 is accepted. Port 6, it says the same thing, TCP 141.92.37, and then the destination is a specific host. Port is the same and accept. If I remove this, if I remove Y, nothing happens. The same behavior will continue because packets um, will match the first rule, so there is no need for the second rule. So this is called redundancy, not shadowing. Shadowing, we call it shadowing if these two rules are not matching. All right, so one is accept and one is deny. So we call them shadowing. But in this case, we call them redundancy because the second one is not needed at all. So the recommendation here is remove rule Y, so I can apply the recommendation and rule Y will disappear. And you can see here rule Y disappeared and disappeared from here as well. So I can do the same thing with the last error here, which is rule 7 with rule 6. Now this one is the opposite. This one is rule X here is the unnecessary one, right? Rule Y is actually a superset of rule X. Because if you compare the two, they are identical except with the source IP address. This one is more specific network, and this one, the Y, has any network. So if I remove 6 here, everything will be caught, the packets will be caught by rule Y, and that will be sufficient. So in this case, the redundant rule is the X rule, not the Y rule. So I can apply the recommendation, which is removing rule X, and that will remove the rule from here. And I can see now that I have eliminated three different types of errors, and I still have 2 anomalies. All right, correlation, you see it here as in orange because it may or may not be an error. It depends on the context. So let's see what the correlation means. Correlation happens between rule 3, the Y rule is 3, and the X rule is 0. And if I compare them here, I'll see. So the correlation happens when one part of the rule is a superset of the same part of the other rule, and vice versa, right? So we can see here that the source IP address is specific, while this one is any. So any is a superset of this specific IP address, or I can say this IP address is a subset of the any. And the reverse is happening on another part. So if you see, this one is the destination here is a superset of the destination in the Y rule, right? This doesn't necessarily be the IP addresses, it could be the ports, or it could be the protocols, it could be any part, right? And you can see that some packets, so the definition here, two rules X and Y are correlated if they have different actions, right? And rule X matches some packets that match rule Y, and rule Y matches some packets that match rule X. So the two are overlapping in some form. Sometimes this is okay, this is intentional. Sometimes in other cases this is not okay, and it's causing some problems. Okay, so let's see. For example, if I look at these two particular rules, I'll see that in this case, in the first case, rule X says that any traffic that coming from this particular host to anywhere, it has to be denied, right? And then in the second rule says anything coming from anywhere, or TCP coming from anywhere going to this particular host is accept. These two now they are ordered okay, so the intention here is to prevent this host from reaching anywhere, and for anybody to reach this host fine. But if I flip the order, I will get totally different behavior from the network. So in this case, I don't have to do anything. It seems like it's the actions or the rules are okay. But if these two for some reason are ordered differently, so the y comes before x, I will get wrong behavior. So that's why um, I have to be careful about the correlation rules. And if I have to investigate them carefully, if they need to be modified, I have to modify them. If not, then that's why. So that's okay. So that's why we call them correlation. All right. So I'm not gonna change anything. But if I need to change, there is usually no way to do the change from the application itself. I have to go and change it from the source file. So I cannot do it automatically like the redundancy and the shadowing. Okay, finally, something called generalization. Generalization is actually not an error at all. It's most of the time it is intentional. So let's take one example of generalization rule between rule number 2 and rule number 0. So here, rule number 0 says that packet with carrying TCP traffic coming from this particular host going anywhere is denied. Right? So we are not allowing this source to send any HTTP traffic. Yes. So we are preventing it from sending any HTTP traffic. Everything else, the rest of the network, the rest of the subnet is okay to send traffic. Right? This is okay. This is the way we do things. We put the most or the more specific rule at the top, so it is executed first, and then the more general rule at the bottom. So in this case, well, there is one particular host in this subnet that I don't want it to communicate using HTTP anywhere, so I'm denying the traffic from that host. And then for all other hosts in the network, uh, they are okay, right? So that's not a problem at all. So the definition of generalization is a rule Y is a generalization of preceding rule X if they have different actions, and if rule Y can match all the packets that match rule X. Okay, so this is the definition, and this is not an error, but it's worth looking at it just to verify that this is the intention. So now I fixed all the rules. So the last step is save my work here, so I can download the rules and I can go and find them in the download file. So that will be it for using this app, and it's a very quick way to check firewall rules and make sure that they are free of anomalies, or all the rules follow the intentional behavior that I want from the network. All right, that's all about getting started with with the firewall policy analyzer. And I hope in future recording I can shed more light and more detail on how to use it. Thank you, and see you in another recording.